questions related to classical mechanics. So before going to start, if you are new to my channel, please subscribe my channel for the upcoming videos. So let us start. This is the 2017 question paper. So here is the first question. The phase space of a simple harmonic oscillator with mass m, force constant k with energy is given by. So among four equations, as we know, the equation for simple harmonic oscillator, that is given by half m a square plus half kx square. K is what? Force constant. So we can just modify, and in terms of momentum, if we write that option B is correct. Okay. So the next question, assuming the fundamental Poisson bracket q comma p equal to 1, evaluate the Poisson bracket p square q square. So as we have here the three conditions for Poisson bracket, so q comma p is equal to delta ij. Okay. Then if we solve this equation p square comma q square, then the final answer we get according to the commutation rule, that is minus 4pq. Okay. So option here D is correct. The next question, the transformation from q comma qi small qi comma pi to capital Qi comma pi is canonical when the following condition is satisfied. So if we observe here the four equations, they are quite look same, but some minus or plus sign you have to observe here. Here the answer, as we know, the summation of this pi, small pi minus capital Pi, differential of qi, that is equal to delta f1, that is an exact differential. So the option here for this question is B. Okay, is an exact differential. For what values of alpha beta is the following transformation canonical? If we solve this equation, so the answer we will get, that is first we should know the rules of Poisson's bracket. Then once if we solve this according to the Poisson's rules, we will get alpha equal to half and beta equal to 2. Just try to do it once again. So the option B here, option A is correct. Alpha equal to half, beta equal to 2. So the next question, if f equal to summation qi pi is the generating function for a canonical transformation, then under the transformation we are lead to. So here there are few conditions for generating function. So these are the generating function f1, f2, f3, f4. So transformations as they have given here. As we know here, f is what? Summation of qi pi. We have to find out second equation, qi pi. So here the answer here, what is that? Small qi capital pi. Option A is correct. Okay, if we see these conditions, four conditions, option A is correct here. The number of independent components of a four-dimensional second rank symmetric tensor is. So as we have here the equation to find out the symmetric, that is d into d plus 1 divided by 2. They have given 4 dimensions, so 4, that means answer 10 is correct. Option C. Find the generator of the following canonical transformation. They have given here values of q and p. Just you have to substitute these values in the generating function. First you should know the formula for p generating functions, then you can use the given data. P equal to minus dou F1 by dou Q with respect to capital Q and small q you have to differentiate. Here Q is what? P tan theta, and capital P is what? Minus Q cot theta. Just substitute these values in these two formulas. You will have F1 equal to Q cot TQ. F1 with respect to small q and capital Q you have to differentiate first. Then after getting these values you have to equate. The final equation that you get is for generating function f equal to q into capital Q cot theta. So the answer is option A is correct. If the Lagrangian of a system doesn't depend on time explicitly, then the Lagrangian is conserved, total momentum is conserved, Hamiltonian is conserved, total angular momentum is conserved. So Lagrangian doesn't depend explicitly on time, then the Hamiltonian is going to be conserved. So option C is correct. The Hamiltonian Jacobi equation for a mass thrown up vertically from the surface of the earth is given by. So where m is mass of the object, alpha is what? Constant, and s is the action, z is the height of from the above ground. Here so Hamiltonian equation, as we know, p squared over 2m minus mgz. That is kinetic energy plus potential energy. Here we are throwing the object upward, so this must be negative. Half m ds by dz square we have to put here, acceleration. Then Hamiltonian Jacobi equation, that is h plus dou s by dou t, as we know, equal to 0 equation. This is standard equation. Then if we substitute Hamiltonian in this Hamiltonian Jacobi equation, then we will if we equate this equation, and here ds by d theta is equal to what? Minus alpha. Just put this value in this equation. So the final answer you will get here 1 divided by 2m dou s by dou z square minus mg z is equal to alpha. Option here C is correct. Okay. Then I hope this video is helpful for you. Like that.